This is Chemistry in the AM. The Olson Doctor report. Okay. Okay. Keep thinking here, bye. Okay. What I do want you to write down is solutions and equilibrium constants. We call this one KSP. Remember what I said? We can use KC, you can use KQ, sometimes we can use KA, KD, well, SP. And S and P stand for solubility constant. Okay. Don't write down the paragraph. Read through it and understand. Saturated solutions are an equilibrium between the solvent reaction and precipitation. KQ expressions can be written. The reactant in the equilibrium is a solid, and therefore concentration can't be altered. It's 100% sodium chloride, 100% in this case sodium phosphate. Example. So don't include solids in your K expression. Now, the KSP part of this, we start with the KEQ expression, but it is just going to be a simplified thing for algebra. You'll see what I mean. So, this is what I want you to write down. Okay? I'm going to pause the video and write this down, and we'll work through it. Okay, we have this down. We'll go right back to what we did before. Let's call it KSP expression. We'll leave a space, and I suggest leave a line of space here, okay? Underneath that, because we're going to just do a little something on it. So leave a line, and then write down what we already know how to do. The KSP expression. So, the solid's not included, but Na, sodium ions, and the phosphate ions. Square bracket for concentration. Q, 4. That's our KSP. Or K. I put KSP. I'm sorry. KQ. I think I want two things at once. That's what we do know how to do. This is not new, right? Yeah, true. Now, what I'm going to do that's new. Products over reactant to solid surface material. Here's what I'm thinking. This is a 1 to 3. I already have a 3 to 1. And I don't normally write in those 1 3. This is what I'm thinking. Right? So, if one sodium phosphate breaks up, and it's in water and it dissociates, how many sodiums come out according to the balance? Change. If one of these breaks up, one phosphate is formed. What does that mean? Rip them apart. Right? If two of these guys break up, how many sodiums form? 6. And two of these, it's a 1-to-1 ratio for phosphate. Right? Okay. Now, we're used to using the variable x. If x sodium phosphates break up, how would we find the amount of sodium ions? 3 times. Except we're going to use the variable s. And for me, it's a crappy variable. I'll try to be, because my s's look like 5s. S, that's our variable, breaks up. 3s of these form, and 1s of these form. Okay. That's just because of the way the formula unit is made up. Okay. And that's why I said to leave a space. And then KSP, we'll put on the solubility product. is, we'll plug in the variable expression for the sodium. 3s, I'm going to put it in brackets, Q, S, the phosphate. I'm getting those from this reason. Now a little bit of algebra. Let's scooch this up. Just making more space. So, 3Q, 3 times 3 times 3, not plus, 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 multiple, right? 3 times 3 is 9 times 3 is 27. One is calculated, go ahead. I'm going to work sideways just because I'm noticing my space. 27, and then S times S times S, we just write down as S cubed. I just skipped around that. The letter S to follow. What that all comes out to be, KSP. Now I combine this. You guys know how to do this, right? Oh. 27 times, well, the number 1 is assumed. 27 times 1 is S, or 27, right? And then the S cubed part times the S to the 1 here is S to the 4. Okay? I know we're at different levels of understanding. 27 S to the 4. That is our KSP expression. This is what we're looking at. My circle went through before. So, I need you to practice a few of these. Let's see. Which ones? I want you to do come up with all 4 of these. This should be good. Okay? I'll give you guys a moment. I'll pause it. You can just skip straight into the answers if you wish. If you think you need the full write-out, go ahead and do that. I'm going to whip through these guys. I'm going to start with K expression, of course. KQ. And BA. There's no, these are balanced. There's no exponents. Now, KSP. With this one, if it helps you, go ahead and write these things in. But this is a one-to-one, BA to SO4. So I need one S and one S. If I wanted to think of it that way, I could, if it helps you, put the S in there, and think, okay, S times S. Like you can do this in your head. But your KSP expression is S squared. See where that comes up? The second one, there's one group of silver carbonate breaks up. You get 2S and 1S. I'm going to go through a few first. So, BG plus square 1, 3, 2 minus KSP equal to, put in my 2S squared, single S. I'm going to work left to right for this one. 4S squared X, which I'm going to squeeze this in here. KSP, the final expression that I'm looking for is 4 times 1, so 4S cubed. Okay. time, you might have 4 times 27. Or it's how difficult the math is. I don't have any like that here, but I'm going to just skip straight to the answer. You see, hopefully you've got 27s to the 4. 4s cubed. Now, if you want to go straight to the answer and you're pretty confident you can do this 99.9% of the time correctly, do it. However, you know how I was writing in the red KQ and then KSP? If you were to make a mistake on your KSP and you had 4s squared instead of 4s cubed, but you showed me your KQ and it was correct, I'll give you 1 out of 2. So, if you want to show all your work, that's an insurance policy in case you make a mistake. If you want to skip straight to the answer, then it's all or none. 0 out of 2, 2 out of 2. Right? You got it right or you got it wrong. So everybody's clear on that? Why you want to show your work if you do? Like I know some of you calculus students and stuff like this. You can just whiz through that, and I think you can. I'm trusting, and it's not just calculus, pre-calculus, whatever. If you know you're good with numbers, go ahead. I'll pause for a second, and then we'll talk about something. Okay. This is the same problem, but I'm giving you the name, and I'm thinking, out of these, I want you to just do the last 2. I think that'll be enough. But this means you've got to get your iron sheet out. Same thing, but now you've got to figure out what silver chromate is, what iron 2 phosphate is. This is your homework. Okay? This is one of those ones where you're going to get 27 times 4 in one of them. You'll have a big number for number 4. Not so much. So first come up with the actual. You only got 2 of these 3. 2 of these 4. I just think you should just do 3 or 4. That's enough practice. And this is homework. The first part, though, is to come up with the formulas. You guys want help with the formulas? Iron sheet. Okay. I'm going to actually. Here's our quiet group. First thing is come up with the formulas in the reaction. So, what is the formula for silver and chromate put together? So iron chart, not periodic table. Silver iron. We've seen it before, so you might know it off the top of your head. What is silver iron? Yeah. Ag with a plus though. And then chromate is in the center. There's dichromate and chromate. Be careful. What's the chromate ion? Cr. It's chromate, dichromate. Cr. O4 with 2. That means the silver chromate put together is a solid. It's Ag2 CrO4. So, double arrow, it separates into its ions. Ag plus. There's 2 of them. And a CrO4. You're going to do the same thing with number 4. Iron 2 phosphate. Figure out what the compound is. Figure out what the ions are. Then the compound separated. Then you can proceed as we did previously. Okay? We'll take these up at the start of the next class. Stop the video. You could do the other 2 if you want some extra practice.